Our next shift register is a parallel in shift serial out shift register. As the name suggests, it takes the parallel input and it will take the parallel output for the same. Okay, but there is a little bit change rather than the CISO and CPO. So with parallel data inputs, the bits are entered simultaneously into their respective stages of parallel lines rather than the bit by bit on the basis of the line with serial data. And the serial output is the same as serial in, serial out shift registered. Okay. Once the data are completely stored in the register. As the name suggests, it take only difference between the serial in, serial out and parallel in, serial out is the data is provided in a parallel manner and the output is generated in a serial manner. That's it. Okay. So we are going to consider the example for the same over here. You can first of all we are going to check the condition. So these four D flip flop are there. Yes, you can check. Clock also applied over here. The only change over here, the additional input is provided shift and a load bar, shift slash load bar. So depending on this input, we are going to perform the operation. That is, if the value is become 1, then it will perform the shift operation. If the value is 0, it will perform the load operation. Right? We are going to see this conceptual diagram, or what is the role of this combinational circuit over here. We are going to use a sequential circuit with the combination, that is 5 AND gate, 7 AND gate are there and 3 OR gate are there to generate the uh, resultant value for the same. So D0 having a AND gate, D1 and the two inputs are assigned over here, G2, G5, G3, G6 and G4, G7 are the 7 AND gates and 3 OR gates are applied over here, and so this combination makes a D input. Okay, generate the specific input for the same. Okay, how this will work, see over here. The four data input lines are there, D0, D1, D2, D3, and a shift slash load bar input is given. 4-bit data is loaded in parallel into registered. Okay, when the shift slash load bar is low, the gates G1 to G3, G4 are enabled and allowing each bit to be applied to the D input. That means if this value is low, that means it performs the load operation from on the basis of the gate 1 to gate 4. G1 to G4 gates are enabled and they load the data input on the corresponding flip-flop. So when the clock pulse is applied to the flip-flop, D is equal to 1 will set and those with D is equal to 0 will reset. Okay, so thereby storing all 4 bits simultaneously. And when shift slash load bar is high, the G1 through G4 are disabled and gates 5 through G7 are enabled. Okay, so allowing the data bits to shift right from one stage to the next stage, and the OR gates allow either the normal shifting operation or the parallel data entry operation depending on the AND gates are enabled by the level on the shift slash load bar. As I told you that if the value of your shift slash load bar is high, then it performs the shifting operation, but G1 to G4 are these four gates are disabled and G5 and G7 are G5 to G3 G7 are enabled and perform the shifting operation for the same. So it does not require AND or arrangement because there is no serial data over here. Okay, so this is how your parallel in serial out work. So see the symbolic diagram show you the representation. For parallel input is given, depending on the shift slash load bar signal, it performs the loading or shifting operation. If the value is 0, it performs loading operation. If the value is 1, it will perform the shifting operation. So one by one bit is generated by this combination of circuit. By these gates are used to perform the serial output for the same register, shift register. Okay, that is all about your parallel.